With the energy transition comes an increased demand for clean energy. Hydro-Québec must double its energy generation by 2050, making electricity transmission an important issue. Hydro-Québec's mission is to provide clean and reliable electricity to all Quebecers at the same affordable rates across Quebec.
Dans le déploiement des nouveaux projets, les Québécois demandent de plus en plus que les lignes soient enfouies, mais l'enfouissement n'est pas aussi simple qu'il n'y paraît. Il faut savoir que tous les projets à Hydro-Québec sont développés en respectant des critères techniques, économiques et environnementaux.
Quebec covers a vast territory, and its electricity generation facilities are located up north, far from the major load centers in the south. That's what prompted Hydro-Québec to innovate in terms of electricity transmission. We developed a reliable and sustainable power system that called for the invention of the 735,000-volt line, a very high-voltage line that allows for better transmission over great distances while reducing the impact of towers on the landscape. Are you familiar with the two main types of power lines on our grid? Transmission lines and distribution lines. The electricity generated in our facilities is sent at a very high voltage via transmission lines to substations. From there, the electricity flows into the distribution lines and then on to our customers' homes, schools, and businesses. Most power outages are caused by events that affect distribution lines. These events include weather conditions like strong winds, freezing rain, or heavy snow that can cause tree branches to fall on the power lines, leading to an outage.
Les lignes de transport sont moins affectées par les intempéries que le réseau de distribution. Donc, quand vous avez une panne d'électricité chez vous, c'est souvent sur le réseau de distribution. Les lignes de transport, comme on voit derrière moi, ils ont des larges emprises, les arbres sont loin, ça prend des très grands événements climatiques pour les affecter.
Here in Quebec, the transmission lines are almost always overhead. They rarely cause outages because they're higher and far away from the trees. Underground transmission lines make up only a very small part of the power system. In Quebec, it's less than 1%. In other parts of the world, such as Europe and France in particular, less than 9% of transmission lines are underground. Quebec's vast territory is better suited to very high voltage transmission. In fact, 1/3 of our 35,000 kilometers of transmission lines are very high voltage. Our demographics also play a part. Owing to our low population density, with people scattered across the entire province, we need a more far-reaching transmission system. In France and elsewhere in the world, lines are run underground, primarily in urban areas and rarely over long distances.
Dans d'autres endroits, comme en Europe de l'Ouest, on a des endroits qui sont plus densément peuplés, où le chauffage électrique est beaucoup moins répandu. Donc, ça va nous aider à faire des moins grandes distances, des tensions plus basses, des centrales proches des villes aussi. Donc, ce qui fait en sorte qu'on peut enfouir plus dans ces endroits-là. Pour transporter la même puissance avec une ligne souterraine qu'une ligne aérienne, souvent, on a besoin de plusieurs câbles parce que l'air nous aide beaucoup à dissiper la chaleur. Donc, on a besoin de beaucoup plus de métal conducteur pour transporter le même courant. Souvent, on a besoin de 2-3 câbles par phase pour remplacer une ligne aérienne.
Underground and overhead transmission lines raise different issues. There may be technical constraints like a river or railroad tracks that are difficult to cross. There may also be environmental constraints like a national park or an archaeological site. It's also important to avoid interference with other underground infrastructure, like the gas, water, sewer, and subway systems. This can make establishing the route and coordinating construction challenging. Accessibility is also an issue. Accessing underground lines to carry out maintenance or determine the cause of an outage is no simple task. As the problems are literally underground and invisible to the naked eye, inspections to locate the cause of an outage are more difficult, which complicates repair operations. A malfunction on an underground transmission line can take weeks to repair. Working underground is more complex and more costly. There are also important technical factors. On an overhead line, the conductor is bare, and the heat released by the transmission of electricity is quickly dissipated into the air. But an underground line must be insulated and protected from environmental factors like moisture, freeze-thaw cycles, roots, and soil movement. It is essential to have a thick protective sheath. A duct bank, usually made of concrete, may be needed to secure the equipment, significantly increasing the cost. And heat doesn't dissipate as easily underground. In fact, it can build up quickly. Left unchecked, it can cause the cable to overheat, leading to anomalies, cable deterioration, and outages. What's more, underground lines generally need to be replaced every 40 to 60 years. In comparison, overhead lines have a useful life of almost 100 years, and that also impacts the cost. In addition, all the layers added around the underground cable prevent the magnetic field from dissipating. This field opposes the back and forth movement of the electrons. That's the reactive effect, called reactive power. In other words, the total power is made up of two components: active power, which is used to operate our appliances, and reactive power, which must be limited to ensure the stability of the power system. Underground, everything that surrounds the cable traps the magnetic field, which then increasingly opposes the flow of electricity during transmission and overloads the power system. That's reactive power. The greater the reactive power, the less room there is for active power. In order to transmit more active power, more operating power, the reactive power must be kept to a minimum. In direct current lines, which are sometimes used to export electricity, that isn't a major factor. But in alternating current lines, which make up almost the entirety of the North American grid, it is. That's the challenge of underground transmission lines, managing the reactive power.
La puissance réactive, c'est un phénomène qui est beaucoup plus présent dans les lignes souterraines que dans les lignes aériennes. Ici au Québec, on a des centrales qui sont très éloignées. On a un réseau à 735 000 volts pour aller chercher la puissance de ces centrales-là. Si on essayait d'enfouir une ligne à 735 000 volts, bien, ça nous prendrait des postes intermédiaires à tous les 5-6 km. En aérien, on est aux 200-300 km. Donc, ce serait beaucoup de postes. Ce serait des coûts très grands. Bien, ce serait tellement difficile d'enfouir les lignes que le câble n'est même pas disponible sur le marché.
It's a universal principle. The higher the voltage, the greater the reactive power. That's one of the reasons why undergrounding transmission lines is so complex. Undergrounding transmission lines isn't common practice anywhere in the world. Even at lower voltages like 315,000, 120,000, or even 49,000 volts, undergrounding is complex and costly. And that's why it's never the norm, no matter the voltage. Underground lines can increase project costs by 4 to 10 times, and that can lead to higher electricity rates for all of us. Even so, undergrounding is a solution that is often asked for by communities affected by transmission line projects. To ensure that project decisions are fair for all Quebecers, from now on, Hydro-Québec will assess the possibility of undergrounding transmission lines during a project's planning stages. These assessments will be carried out in exceptional and clearly defined situations. When the line has a voltage of less than 700,000 volts, doesn't pass through an existing corridor, or faces technical or environmental constraints that cannot be bypassed. For example, when there isn't enough space for an overhead line, like in a downtown area, or when there's an unavoidable obstacle like an airport or a protected area like a National Historic Site. For all its line projects, Hydro-Québec makes sure to develop the best proposal, taking sustainability practices into account. We always strive to strike a balance between maintaining the reliability of the power system and respecting the environment and communities involved. That's why all our line projects start with a rigorous technical, economic, and environmental assessment. We understand the importance of meeting Quebecers' expectations. For each project, we implement specific measures to minimize impacts.
L'évaluation environnementale permet d'élaborer des bonnes mesures d'atténuation. On parle par exemple de diminuer le nombre de pylônes le plus possible, d'ajuster la hauteur des pylônes ou d'ajouter des écrans végétaux pour atténuer les impacts sur le paysage.
It's important to remember that undergrounding also has negative impacts on the environment. All these considerations come into play in Hydro-Québec's decision-making. Our objective is to always make decisions that are in the best interests of society.